Hello everyone, it's Ben Voigt with CNC Labs. I'm a design engineer who worked on the AltMill MK2, and today I'm going to be walking you through the steps to build the machine. We're going to be breaking it up into 7 different steps, starting with the table assembly, putting the gantry onto the table, installing the Z-axis assembly onto the gantry, installing the motors onto the machine, putting the drag chain end links on, doing the wiring and spindle installation, and finally finishing off with the controller setup. All right, let's get to it. The first thing you're going to do is lay out the 2 Y rails on the ground and the 5 cross beams with the flange face contacting the ground. Something you're going to want to note about how I've laid out this machine is I've laid out the back of the machine towards the camera at this point. That's because later on we're going to be flipping the tabletop over onto the upright position, and then that'll allow the front of the machine to be towards the camera, which is how I want it. So you can think about that while you're building your machine. It can save you a little bit of time so that you don't need to spin the table around. The way that you're going to know what the front and the back of the Y rails are is there's 2 different bearing block styles on each side of the ball screw. The style with 4 screws fastening the bearing block to the Y rail is the back of the machine. When you lay out the cross beams in between the Y rails, you're going to want to make sure that on the front and the back cross beam, you have this flange pointing inboard. Now, the rest of the cross beams, we recommend that they follow the same convention as the front cross beam and have the flange pointing towards the back of the machine. That helps make sure all the cross beams have a consistent hole pattern when you're screwing down your wasteboard onto the cross beams. Using the M5 tall head screws, you're going to put 1 screw into the top hole of each of the 5 cross beams on one side and leave those loose. There is a reference ledge on the inside of the Y rails that the cross beam is going to sit on. On one side, rest the cross beams on that ledge and install 1 of these tall head M5 screws into the top hole of the Y rail. Leave the screw loose in the cross beam, and the only purpose of this step is to help with seating the cross beam on the other side's reference edge. It makes it so the cross beam doesn't fall off the first side's Y rail reference edge when you're putting it on the other side. Once you've installed 1 screw into the top hole of each cross beam on the other side, and you've got all 5 cross beams seated square onto both reference edges, you're able to move on to installing the remaining screws into all 5 of the cross beams. There's going to be 13 screws on each side of the machine. Something to note is the front and the back cross beams have 2 screws installed on each side instead of 3. When installing the tall head screws into the cross beams, be sure to use the 4mm hex key provided in the kit and not a drill or an impact driver, because you're at risk of stripping the internal threads of the cross beam with the excessive torque on a drill. Now we are going to install 2 of the legs, and this is how you prepare them. Take 1 nut off of the top of each of the 4 leveling feet and insert it into the bottom hole of the leg. You can loosely put this nut back on. You'll be adjusting it later on. Next, you're going to install a T-nut, an M6 T-nut, and an M6x14 button head cap screw onto the flange face of the leg that is going to interface with the cross beam. There are 4 holes on the flanges of the legs. The 2 top holes will be used for the M6s with the T-nuts going into the crossbeam, and the 2 bottom holes on the other side will be used to fasten the leg onto the Y rail. It is helpful to put the leg next to the machine where you're going to install it, so you ensure you install the M6s and the T-nuts in the correct flange. Make sure the other flange slips in between the ball screw and the Y rail when you're installing the T-nuts into the crossbeam. Once you've put the T-nuts into the T-slot of the crossbeam, don't tighten the M6s all the way. Leave them a little bit loose at first. Once you tighten the screws into the Y rail, you can move on to tightening the T-nuts. Now install the second prepared leg on either the front or the back side, the same side that you've installed the first leg on. In my case, this is the back of the machine. We're going to be flipping the machine now, and you'll need 6 feet of space in front of the edge of the machine that does not have the table legs attached to it. We're going to be flipping the machine over that edge. So there needs to be 6 feet of space in front of that. The table is flipped, and we've put a stool underneath the front of it to support it from coming down. And the next step is putting 2 prepared legs onto the front of the machine. The table legs are installed into the front of the machine in the same way that we installed the first 2 table legs. Be sure to insert the T-nuts into the T-slot of the crossbeam, leaving those screws loose at first, and then insert the M6 by 14 millimeter long button head cap screws into the Y-rail, and at that point you can tighten all 4 screws up. Once all 4 legs are on the machine, this is the time to level the front and back and the side and side to make sure that the tabletop is as close to level as you can get it. The way that you do that is by adjusting the leveling feet, the nut underneath the leg. You can use this cutout on the custom wrench to rotate the nut on the bottom of the leg to level that specific leg. It's an iterative process leveling the machine where you need to go from leg to leg as you check the level on the front and back plane and the side to side plane. This process will take a certain amount of time, but it is important to get it right. One thing to remember is to level the machine where you plan on leaving the machine, as the floor in your shop might not be consistently flat throughout. You don't want to have to adjust this twice. Before I move on to the next step, we're going to talk about the orientation of the machine and the 2 different sides. We're going to talk about the machine from the vantage point of you looking at it from the front and how the camera sees the machine right now. This is the left side and this is the right. We'll be putting the 2 Y-axis cables through the top section of the Y-axis rail, the left side, from the back to the front. Something you'll have to note is which side to put through. So looking at a Y-axis cable, and keep in mind all 4 of the different cables have the same connectors, but they're different on each side. These ones here with 2 green and 1 black is the motor side. This here with the green, black, and white connector, that side goes to the controller. This is the side that we're going to be putting through the Y-axis rail from the back towards the front. You'll be inserting both wires through the top section of the left side Y-rail at once. Push the 2 harnesses through the rail until there is about 45 centimeters or 1.5 feet sticking out from the front of the machine. We'll be preparing the Y end plates before we put them onto the machine. The way you prepare it is by putting 2 T-nuts and 2 M6 by 14 millimeter button head cap screws onto these 2 slotted holes on this sticking out section of the end plate. You'll also install a bump stop using a M5 by 16 millimeter socket head cap screw onto the same side of the end plate that the T-nuts are sticking out of. Now you'll know what side to have the T-nuts on depending on which face will be contacting the crossbeam. Remember that the T-nuts will be inserted into the T-slot of the crossbeam. So for this plate here, it will go on the front right corner. Whereas if we were to try and put it on the other side, it would be in the opposite orientation of how it should be. You see the T-nuts are on the wrong side. After you've prepared all 4 Y end plates, you can install them onto the 4 corners of the machine. You'll do that by inserting the T-nuts into the T-slot of the crossbeam and using 3 M6 by 14 millimeter long button head cap screws into these 3 holes, which will fasten the plate onto the end of the Y-axis rail. While installing the 2 end plates on the left side of the machine, you'll need to make sure to slip the 2 cable harnesses into this cutout at the top before you fasten the end plate to the Y rail. On the 2 Y plates at the back of the machine, they will each have a inductive sensor inserted from the back into this hole. To prepare the inductive sensors, thread a nut about 3/4 of an inch down from the blue tip and put a lock washer. Insert the inductive sensor through the back of the plate so the blue tip is on the same side that the bump stop is on, and install a lock washer and a nut onto the front of it to secure the inductive sensor onto the plate. Before you tighten the inductive sensor nut onto the front, you need to make sure the sensor is sticking out of the plate far enough. You'll use the bump stop as a reference. You cannot allow the blue tip of the sensor to be past the face of the bump stop. This is because when the machine is being used and the Y gantry plates contact the bump stop, you do not want those plates to hit the sensor and break it. Use this wrench and put it against the face of the bump stop to see how far away the tip of the blue sensor is from the bump stop face. You want it about 1 to 2 millimeters away. Once you've confirmed the stick out is correct, you can tighten the nut securing the sensor to the plate. Table assembly is over and we're moving on to installing the gantry. The first thing to note when installing the gantry is the two Y gantry plates. Now they're different. This will be the front, this is the back. This is the left side gantry plate. You can know that because there's a big hole and the motor is going to go through there for the X-axis. We'll start with installing this plate. The second thing to note about the Y gantry plates is the reference edge on the inside. This reference edge is going to be resting on the linear bearings, and it is important that it sits flush and flat on those bearings. We'll be installing M4 by 16 millimeter long socketed cap screws into these 8 holes on the side of the Y gantry plate. I recommend that you start with putting just one screw into each of the hole patterns so as to connect the Y gantry plate to one linear bearing at a time. There's a plastic bracket holding the ball screw nut secure. You can remove that and throw it away. Take the linear bearings and push them towards the front of the machine because this is where we're going to be installing the Y gantry plate. When installing the M4 by 16 millimeter socketed cap screws, you can use the 3 millimeter provided hex key. Leave these screws loose for now, as later on we will be putting the X rail in between the two Y gantry plates, and it is much easier to install the X rail if the gantry plates have a certain amount of play in them back and forth. After you finish installing all 8 M4s into the linear bearings, push the Y gantry plate all the way forward to the limit of the machine where it hits the bump stop. We'll install the right side Y gantry plate in the same way. Using your hand, push the ball screw nut block toward the front of the machine and match the holes at the bottom of the Y gantry plate to the 4 threaded holes in the ball screw nut block. You'll attach the ball screw nut block to the Y gantry plate using these M5 by 20 millimeter long socket head cap screws. And a reminder note to leave these screws loose for now for the same reason that we left the M4s loose. It is easier to match the holes of the gantry plate and the ball screw nut block by moving the gantry that's on the linear bearings than it is to adjust the ball screw nut. Feel free to match the holes in that way, but remember afterwards to push the Y gantry plate all the way to the front of the machine once again. You'll install a bump stop onto each of the Y gantry plates on the inside of the plate, and also you'll install a sensor into the left side Y gantry plate, keeping in mind that the sensor cannot stick out past the bump stop. And remember to use the custom wrench to check just how far away your sensor tip is from the face of the bump stop. Once you've installed the 2 bumpers and the sensor onto the Y gantry plates, it's time to put the X rail onto the gantry plates as well. Place the X rail on top of the machine so that the AltMill logo is reading with the letters upright, and you'll notice that there is a slot on the top of the X gantry plate, that's the black plate on the X rail. That slot needs to be on the top of the rail. You'll install 2 M6 by 35 millimeter long flanged button head cap screws into the top 2 holes on either side of the X rail. When you're threading them in, you can thread it into just about where you lose sight of the blue Loctite that's on the tip of the screws. You'll want to make sure that there is 20 millimeters or 3/4 of an inch of thread still exposed on the outside of the rail so that the screws can sit into the pockets that are on the top of the Y gantry plates. We also recommend that you use another person to help you out when you're lifting the X rail onto the gantry plates, because it makes the whole thing far easier than trying to do it by yourself. You've put the X rail onto the gantry plates. Now it's time to tighten all the screws that are on the side of the gantry plate. The screws you're going to start with are the M4s. It's important you start with the M4s because those are the screws that are tightening the gantry plate onto the linear bearings. You want to make sure that the reference edge is sitting flat onto those linear bearings, and the best way we can do that is if we tighten those screws first. So use the 3mm hex key to tighten up all 16 screws holding the two Y gantry plates onto the linear bearings. When tightening the M4s into the linear bearings, be sure not to tighten all 4 on one bearing and then all 4 on the other bearing. Go back and forth between the two linear bearings and tighten the screws in a cross pattern to try and make sure that the screws get tightened against the linear bearings as evenly as we can. After you've installed the linear bearing screws, you're able to move on to tightening the screws that connect the Y gantry plate onto the ball screw nut. And then you'll use a bar clamp similar to the one I'm holding, to which you'll clamp the back of the X-rail and the front of the left side gantry plate, squeezing them together because there is some vertical reference edges here and here on the Y gantry plate that the X-rail needs to be pressed into so as to make sure that it is in the correct position before it's tightened. Place the clamp near the large hole on the left side Y gantry plate, being sure that the clamp is contacting the back face of the X-rail and the front edge of the Y gantry plate. You'll notice that the X-rail does extend past the back face of the gantry plate, which allows you to contact it before the end of the plate. Tighten the clamp up and visually check to make sure that the machined face of the X-rail is contacting the reference edges. Then insert 2 M6 by 35mm long flanged button head cap screws into the 2 bottom holes on each side, and you can tighten all 4 screws at this point. Before we move on, I want to remind you that you only use the clamp on the left side rail and gantry plate, not the right side. And leave that clamp attached while you're tightening the screws into the rail that clamps the Y gantry plates to the X-rail. Once you've tightened the 35mm long M6s, you can tighten the M5 by 20mm screws, clamping the Y gantry plate to the ball screw nut. And that finishes up the gantry assembly. Next, we'll move on to the Z-axis assembly installation. Moving right along, we are now at the section where we will be installing the Z-axis assembly onto the gantry. The first step involved in that will be to get the 80mm router mount and put it onto the Z gantry plate of this Z assembly. That's this plate right here. You will install the 80mm router mount to the Z-axis assembly using 2 M6 shoulder bolts, and those 2 bolts will go through the top holes on each side. You'll know which way to orient the router mount by looking at these 2 screws that will eventually tighten the bore that the spindle sits in. These screws need to be on the right-hand side when you're looking at it. Start by installing the shoulder bolt on the right-hand side. It is important to start on the right-hand side due to alignment purposes. The left-hand side hole is in fact a slot. Use the M6 by 25mm long button head cap screws to fasten the bottom 2 holes of the router mount. You'll install the drag chain mounting bracket onto the back of the Z-axis assembly on these 2 holes right here using 2 M5 by 10mm long socket head cap screws. Install the bracket such that the flanged face, the short one, is pointing downward. We'll install the last inductive sensor through this hole on the back of the Z-axis assembly with the blue tip going through this hole. To access the hole from the other side, you'll need to adjust the ball screw to move this Z gantry plate downward. Give yourself some space to work. You need to make sure the sensor tip does not stick out past the height of this pocket. You do not want the ball screw nut to contact the sensor when it goes to the top of the Z travel. On this sensor, you can leave the lock washer off as it is difficult to fit both the washer and the nut. We'll use 2 M6 shoulder screws as locating pins. One is inserted on the back of the Z-axis assembly, and the other gets put into the X gantry plate on the bottom. Do not tighten the shoulder screw into the X gantry plate all the way, as it will be tightened against the Z-axis assembly later on. Next, we will put the Z-axis assembly onto the gantry. You're able to tighten the M6 shoulder screw that is on the bottom of the Z-axis assembly and will clamp it against the X-axis gantry plate. You will also use 4 M6 by 14 millimeter long button head cap screws to fasten the Z-axis assembly to the gantry plate. To access those holes, you will need to adjust the ball screw to bring the Z gantry plate upward. On to motor installation. We're going to be putting the 3 motors onto the 2 Y-axes and the 1 X-axis. Before we install the motors, we'll be preparing them by putting the motor couplers onto the shaft. On the motor coupler, there's a 10 millimeter side and a 8 millimeter side. The 8 millimeter bore will fit onto the shaft of the motor, and you can insert that until it bottoms out. Then, using the 3 millimeter hex key, tighten the set screw on the side that'll clamp the motor coupler to the motor shaft. Using M5 by 10 millimeter long socket head cap screws, you'll install the 3 motors onto the 3 separate axes. Insert the motor coupler onto the shaft and then tighten the motor onto the respective plate. Something to note about the orientation of the motor while installing it is the dip switches must be on the bottom. This is important for later on while installing the motor covers. Don't forget to tighten the ball screw side of the coupler once you've installed the motor. We do not recommend you change these dip switches from the stock setting, as the dip switch positions will coincide with resolution values on the firmware side of things. If the resolution in the dip switches are not synchronized with each other, the micro-stepping will not work properly on the stepper motors. We need to remove the 4 drag chain end links from the 2 different drag chains. An important note is the end links are of 2 different styles. One has a knob and one has a hole. They need to be kept together as a pair for one drag chain, or else you will have a hard time connecting the drag chain to those links later on. When you're putting your drag chain end links in position, you'll put the one with a knob on the Y-axis assembly and the one with a hole over towards the left side of the machine. That will be for your X drag chain. Then knob right beside that on the left side of the X rail, and down at the bottom on the left side of the Y rail, hole. That pair will be for your Y drag chain. Insert 3 M5 T-nuts into the left side of the X rail T-slot and 1 T-nut on the left Y rail at the front. We will use M5 by 10 millimeter long socket head cap screws to tighten the end links into place using the previously installed T-nuts. We will use 2 M5 nylock nuts to fasten the drag chain end link onto the Y-axis assembly. It is important that this end link has the flanges pointed to the right side of the machine when you install it. And again, we will be using M5 by 10 millimeter long socket head cap screws to fasten the end link. You can use this cutout of the custom wrench to hold the M5 nylock nut. Link the 2 pairs of lengths together, and those will be your 2 drag chains. Before we finish up this chapter, I'm going to get you to open up all the top clips on each of the drag chains so that they are ready to receive the wire harnesses in a future step. You do that by using a small flathead screwdriver, inserting it into the side of the clip, twisting a little bit, and it'll pop the clip right open. There is a specific side on the drag chain top clip that has a small screwdriver symbol. That is the side that you will insert your screwdriver into and twist to get the clip to pop open. Put the 2 prepared drag chains to the side, and we're going to move on to the wiring and spindle installation. You will receive 4 of these cable hangers in the AltMill package, and you can put 3 or 4 of them onto the back crossbeam so as to allow you to put the Y2 cable harness into these cable hangers. Make sure when you are installing the cable hangers, you have the gap upwards. The way you install the hanger is by twisting it into the T-slot and rotating clockwise. Fit the Y2 cable harness into the cable hangers, but do not plug the cables into the motors at this point. The next steps are only for people who have purchased the CNC Lab spindle kit. If you have purchased a third-party spindle, you should look at the instructions for your specific spindle and come back to these instructions once you are at the point where you are able to route the cables through the drag chains. For those of you who have bought the CNC Lab spindle kit, we're going to start by attaching the VFD unit to the VFD mounting bracket. You'll do that with M5 by 16 millimeter long socketed cap screws and 2 M5 nylock nuts. We will install the VFD and the mounting bracket to the inside of the left side leg using 2 M5 by 16 millimeter long socketed cap screws. Loosen the 2 screws on the front of the spindle mount to prepare it for inserting the spindle from the top. Take the spindle out of the packaging and place the packaging underneath the spindle mount. By turning the motor coupler, adjust the distance from the bottom surface of the spindle mount to the top surface of the spindle packaging. Make the distance 4.5 inches or 110 millimeters. Insert the bottom of the spindle into the top of the spindle mount. Tighten the 2 clamping screws on the side of the spindle mount. Go back and forth between the 2 screws so as to tighten them evenly. Unravel the spindle cable and bring it through the machine from the back of the left side table leg, underneath the gantry, over top the spindle, and plug it in. Note the keyed features on the tip of the spindle connector and the slotted features on the spindle body plug. You need to match those features so that the connector can plug into the receptacle. Then, adjusting the collar on the outside, tighten it by turning it clockwise to secure the connector to the receptacle. I recommend that you remove half the top clips of the drag chain, as it makes it a heck of a lot easier in the future if you ever need to open it back up and get at those wires or put a different wire in. It saves you, well, 50% of the time. Take the drag chain and place it on the top of the x-axis. Be sure to note the knobbed feature and the hole feature on each side of the drag chain and match it with the drag chain end links. We will now fit the spindle cable and the Z-axis motor harness into the drag chain. Remember to note the 2 different sides of the cable harness, where the connectors with the green, and black connector stay on the motor side, and the green, black, and white connector go towards the controller. Note the amount of wire sticking out from the drag chain end link. As you install the cables into the drag chain, you can clip the links along the way to keep the cables from falling out. You can plug the connectors into the top of the motor, noting that the wires come down on the back side of the motor. This helps you make sure you have the correct amount of wire harness sticking out from the drag chain end link. Click the end of the drag chain onto the end link and begin to fit the rest of the 2 wires into the drag chain. You can clip the other side of the drag chain onto the other clip as well. Place the drag chain onto the y-axis and fit the X harness, the Z harness, and the spindle cable into that drag chain. Once you have all 3 cables encompassed by the drag chain first link, you can click it into the end link. At this point, you can plug the cable harnesses into the motors. When installing the 2-pronged power cable into the back of the motor, be sure to use the 2 screws that are on the cable and fasten the cable end into the motor. And insert a motor cover onto the top of each of the 4 motors. You will need to remove 2 M3 socket head cap screws from the top of the motors and replace it with 2 of the provided M3 by 40 millimeter long socket head cap screws, which will fasten the motor covers onto the top of the motors. Note the opening on the motor covers that will allow the cables to exit the cover. We're nearly done. All that's left to do now is put the controller onto the left side leg, install the e-stop, and plug the wires in. The first step is to put the e-stop onto the side of the left side leg. The e-stop is located in the SLB EXT box. If you haven't purchased the CNC Lab spindle kit, you will need to use the 3D printed bracket that is included in the SLB box to mount the e-stop to the side of the left leg. The bracket fits in from behind the leg into the pocket, and the e-stop is mounted onto the front of it after you've installed 2 Nylock M5 nuts into the back of the bracket. To install the e-stop to the side of the leg, you'll use 2 M5 by 16 millimeter long socket head cap screws. If you have purchased the CNC Lab spindle kit, then you will install the e-stop onto the side of the left leg, threading 2 M5 by 16 millimeter long socket head cap screws into the 2 threaded holes of the VFD mounting bracket that is already installed in the inside of the left leg. Install an M5 by 10 millimeter long socketed cap screw and a M5 T-nut about the left side of the left leg with the T-nut on the outside of the leg. This will be used to attach the controller onto the side of the left leg. Leave the T-nuts loose on the M5 by 10 millimeter long screws. The holes that the T-nuts will go through are underneath the AltMill logo on the left side of the left leg. Fasten the controller to the side of the leg. Starting with the X and Z cable harnesses, fit them into the top cutout of the right side of the controller enclosure. The white ports are for the sensors, the black for the motor controls, and the green ports for the motor power. The motor power cables can be connected to any of the 4 inline green ports. But take extra care to ensure the sensor and motor control cables are connected correctly to the respectively labeled white and black ports. The 2-pronged power ports does not matter which port you plug it into, but we recommend you start from the left and move your way across as you plug in the Z, the X, the Y2, and the Y1. Insert the Y1 and the Y2 cable harnesses into the bottom cutout of the controller enclosure. Install the green end of the e-stop cable into the front of the controller and the clear side into the back of the e-stop. This is your power supply. You'll plug the green end into the back of the controller and you'll plug the 3-pronged end into your wall outlet. Plug the clear connector, which is the VFD controls, into the back of the controller to the port that says RS485. Congratulations, you've now finished setting up the AltMill and you're able to turn the machine on using the switch at the back of the controller. From this point, you can move on to the next section of the resources and learn how to begin the first movements on your machine. If you've liked this video half as much as I've enjoyed making it, give us a thumbs up, give us a comment on your thoughts, let us know how you found your AltMill build, and I look forward to seeing you guys in the next video. Bye for now.